So hey guys, welcome to the day 9 of Leetcode daily until I get a job. So today we have these two questions, as you can see my screen here. Minimum window substring and sliding window maximum. These are two really good questions of sliding window, if you have heard about them. So we'll be doing them today and we'll try to do them within 30 minutes. So okay, obviously some of the last videos are all above 40 minutes, but yeah, that's our target, to do it in within 30. And wait, let me just reduce the voice. Yeah, that's fine. Okay, so we will start with the first question, that is the minimum window substring. So we were given with one string, we are given the two strings actually. Let's reload it. Okay, given strings s and t of length m and n, return the minimum window substring of s such that every character t including duplicate in s is included in the window. If there is no such substring, return the empty string. Okay, so we have done the similar question in yesterday's CSES 1 hour speed run. So that's a similar question, but there is a quite a bit difference, that in yesterday's question we need to find the exact substring ABC, means the any rearrangement of this particular string we needed to find yesterday. But in this we can find any substring that must contain all these characters. Okay, so yeah, we can think of an approach somehow that let us take a map firstly. If we take those inputs, okay, we have these input here. Now for these inputs, if we take a map, firstly a map will be needed, right? What we will do in that hash map is we will store the occurrences of these characters from the t. Okay, what we will do is we will store in the map that a is coming one time, b is coming again one time, and c is coming one time. So we have to find a substring in s which have these characters with these frequencies. Okay, so now I'm checking constantly that it doesn't happen that, like yesterday when the video was having breaks in between, and there were some breaks in yesterday's CSES video, and those breaks were lost actually. The recording automatically stopped and then started after a break, and because of that some part of questions were missing, but that's fine, we will try to avoid that thing from now on. Okay, so what we can do is, now we will start from here. We will take two variables, I and j. Okay, and if we take I and j here, then j will be incrementing and I will be the starting of that substring which we require. Now let us casually see that we want ABC in a substring. If we start from here, A is here, then we have B, then we have C. This is the first substring we have, which have all the three characters. But what we need to do is we need to minimize the length of this substring. Okay, we have to find the smallest substring of that type. So what we can do is simple, that we will start from here. Okay, if MP of Sj is greater than 0, if it is greater than 0, like if this element exists in this map. Why will it exist in the map? Because it is present in t. If this exists in the map, then we will increment the j. And other thing which we did yesterday was take the size of this t. Size of this t, let's say count. we have a variable count and we store it in its size, and it is currently 3. Okay, so now whenever we will find any character that belongs to T, that is which is in the map, we will increment the j and we will minus it. Right, mp of s has j minus minus. We will remove it from the map. Another thing we will do is we will decrement the count. Count basically signifies that how many characters we are yet to search in S which belongs to T. So we have found one of the characters A, so we'll decrement count, so there are 2 more characters now. Okay, now next we will go to D. Obviously the map doesn't have a character as D, so it will like continue the loop. O, it is not there. B, it is there. So if B is there, again we will do what? Obviously J will be incremented anyhow, don't worry about that. So B is there, so the same will happen with B. Now the count will be 1 more character we need to find. And when we find E will be skipped. When we find C, then okay, when we find C, we have all the 3 characters because count is now 0. Okay, count is 0 now. And one more thing, which is that we will just decrement the count of every element we get. Like see, A is there, we decrement it, now the count of A becomes 0. Count of B is now 0 and count of C is also 0. And those elements which are not found in the map, their count will be, let's say anything which is not in the map, their count will be -1 now. Okay, we will decrement it, whatever it is, we don't care. Okay, if it is greater than 0, it will be 0, and if it's not there in the map, then it will be -1. Okay, rest of the characters have, D has a frequency of -1 in the map, O has a -1, B has a -1, B has 0, E has a -1, C has 0. Okay, so it has these both 3 has 0, other have -1. Okay, so now what we can do is, when the count becomes 0, we know that we have found all the characters. First thing is we will update the length. That answer will be equal to j minus I. Right, j is what? Here j is 1 2 3 5. J will be here, right? J is 5 and I is 0. So 1 2 3 4 5 6. J is 5. So answer will be j minus I. Okay, 5. And we just don't have to return this length, we have to return the substring actually. So this will be our answer, and I will be, let's say, the start of that substring. We will assign it a variable head, and that will be equal to I. Okay, this is the first thing where we will do when we have a count as 0. Now we will slide the window, right? How we'll slide the window is, we will take the I. If this map of I, if map of Si, we will check if it is equal to 0, we will do what? We will do count plus plus. And why will we do that? Why will we do count plus plus? We know that only those element has a count 0 which were there in T. Otherwise all the other characters have a count of -1, right? All have a map value of -1. Only those character A, B, C have a map value of 0. So if they are 0, we will increase the counter and increase the I and increase the MP of SI. Okay, so it's simple, right? That whenever if we are at I here, and this character is what we need to find ultimately, then obviously we will increase the count, right? When we are going forward, we are discarding this element, so we have to find it somewhere else going forward. Okay, so we will do that. Else what? Else if anything is not there, we will just increment I plus plus, right? We will just increment I plus plus and MP of I plus plus also, MP of SI plus plus also we will do, because whatever have -1, if we are discarding them, let them make 0. Okay, now it will be 1, they will made 0 going forward. Okay, they will made 0, and if they are found, they will make 1. So in this way, again, whenever we will found the count 0, we will update the answer. So it will work in this way. One other, let's go forward with this example only. We have seen here. Now we have found this. Now this loop will be running, this thing will be running, which is the process I just explained, while C is 0. Whenever C is greater than 0 means we do not have a valid string, then we will do this process. Okay, until the count is 0 again. So C is here. So when we discard I will be at D and count will be 1, because we discarded a, right? Then this is the window, and we will go forward now. O, D, E, B until we find a A. Okay, and now pay attention that we find a A here. So this will be the string, but pay attention that this has a one more B. So B will have 1 as the frequency now, and A will have 0 when we reach that A, and C will have again 0, but B have 1. And what does this 1 signify is that we can discard 1B. We can discard 1B and still have a valid string. Okay, so we will now we have again count as 0. We will update this as the answer. Okay, and if MPSI is 0, we will do count plus plus. No, we will not do. Remove it. Now see here, MP of SI, it is 0. No, it's 1. For B it's 1. So we will again move forward, and its occurrence will be now 0. Now we cannot remove the next BV yet. Now we can remove this as well. And when we are here, see, this can be still answer. CODEBA. Okay. Now if we remove C from here, count will be 1 again. Then we will go forward N, and then we find C. And then we will start moving from backward, that we will remove O, we will remove D, we will remove E. Now we can not remove B. Okay. At B, when we are at B, answer will be again updated to 4, B, A and C. Now if we remove this B, count will be plus plus, and then if we try to go further, the string has ended, the loop will be returned. We will have the answer length as 4, and we will have the starting as B. Okay, we will have the starting length as B. Now what we can do is starting index we have, and that index is this. Okay, this is I, or head, this is head. So we will do what? We will just return the answer as s dot substring. We define the length, that is answer. No, we define the first character, first index, starting index, that is head. Oh man, let me do this. Head, and what is the length of it? That is answer. Okay, and that will be our answer. So in this way we will do this. Let's write the code for this now. So it's simple that firstly let's take a map, right? Okay, let's do this quickly. Unordered map char I int, we will just do what? Empty of I plus plus, and we will have a variable int count as t dot size, and after that we can have a variable head which is currently 0, I 0, j also 0. Okay, and now we will start iterating the second loop, that while j is less than s dot size, we will do what? If mp of sj is greater than 0, then we will do what? Count minus minus, and we have to do the j plus plus for every element, right? So we will do it right here. Whenever we are checking, j will be incremented, post incremented, and this map will be post decremented. Okay, it will work fine. This is same as this. Okay, you don't have to worry about all it. This is same as this thing. So yeah, we are doing this. Our video is fine. Okay, that's that. Yeah, that's good. Okay, we have this, and after that, while count is 0, जब तक count 0 रहेगा, what we need to do is we will have to firstly update the length. Okay, our initial length is int x. So if the length is less than length is greater than j minus I, we will do length is equal to j minus I. Okay, oh man, what we can do simply is len is equal to min of len comma j minus I. Okay, we have this length. Apart from this, what we need to do is simple, that if we will now slide the window, if mp of si is 0, what we need to do is count plus plus, and we don't have to do it count plus plus in any other cases. If we have to only do it if the characters we found are a or b or c. In all other cases we have to increment the I. In this case also we need to increment the I. So I will be incremented in every case, and this map will be incremented also in every case. Okay, so and this is actually same as this condition. Yeah, all these conditions, actually it is same as that. That if mp of si is 0, we will do what? We will increment count, we will increment I, and we will increment its frequency in map. Else, if it's not 0, if it's minus 1, well, in that case we won't increment the count, we will do rest of the two things. So these two things are common, right? We can do this in the if only, and we are done with it, right? So after that, if we just need to do what? That we have to return the s dot sub string sub str. First is the head. We didn't assign the head, right? Okay, we can do it right here. Head is equal to I. Okay, so we can assign it right to head is the starting and length is the length. Let's try running it. output is A, third case. Why is it so? If we console, see out the length, what will it be? Let me just this silent. Okay, so in this case, okay, we have the length as int max, but it should not be the case, right? If the length is int max, then obviously this whole thing doesn't work and we didn't find the required substring. Then we can do one thing. If length is equal to int max, then we have to just do this and else this. We can run it. Yeah, it's fine. And we can submit it. Yeah, okay, there is a error here. Output is AEFG, expected is CWAE. There is no C in our output. Right, how does this thing work? What's the error? We will decrement the count here, right? And then we will run the while loop while count is 0. If length is greater than j minus I, let's do this. If the length is greater than j minus I don't know it will make a difference or not, but then length is j minus, head will be assigned I. Okay, length will be this, and otherwise we will just increment the I and its count in map and increment the count also, right? In this if condition, in this if condition we have done this. J is incremented every time, not a problem, and this is being incremented, that's fine I guess. But why? Maybe head was the problem. Yeah, our head was not updated with I, maybe that was the problem here, but now it's done. 100% time complexity, nice one. Okay, next we'll go to the sliding window maximum. This is a really good question, like as far as interviews are concerned or anything else. I've seen this question a lot, and this is really good question. And we can learn a new concept from here, which is DQ. We have a Q here, so we can learn a DQ from here. Okay, so that concept is let me see if the video is still on. Wait, yeah, it's working fine. Okay, so what we can do here is that we have this array. Okay, let's just copy this thing. We'll paste it here. We have this example. Okay, so we have to take windows of 3 and we have to find what is the maximum element there. So what we can do is this, if this is our resulting array, answer array, so 3, we will take a window of 3. This is the window of 3. What is the maximum in this? 3. Next, what is the maximum in these 3? Again it's 3. Now next window, what is the maximum in these 3? It will be 5. What will be the maximum in these 3? It will be 5 again. What will be the in this window? It's again 6, and in this window we will have 7. So obviously number of windows we will have is n minus k plus 1, right? So here the length is 3, 3, 6, 7, 8. So 8 minus 3 plus 1. that is 6, and we have 6 result for 6 windows, and this is what our answer says, right? Yeah, 3 3 5 5 6 7. So we have to do it this way. So let's try to find an approach. So we are talking about DQ here. Okay, DQ is something we know about. Q is what it's basically work on first in first out. So this basically a line where we can insert from only end, and elements will be going out from only front. So who will enter first will leave first. This is what a Q means. But what means in what a DQ means is that we can insert from front also, we can leave from front also, we can insert from back also, and we can leave from back also. Okay, this is what a DQ means. It's a double-ended queue basically, and we have the flexibility to like input or output any element from any of the side of the queue. Okay, so what we will do is we will insert the elements in there, and we'll take the element from the front, which is the maximum for that window. Okay, so what we will do is we will iterate this array. So from 0 to n we will go, we will run a for loop from 0 to n, and what we will do is we will insert this element into queue. Okay, so we will just in the DQ we will push the index of the current number. Okay, current element, we will push the index of it. If the DQ is not empty, we will write a if condition now. If the DQ is not empty and the current element means the DQ dot front means this element, which we are considering that this will be always be the maximum in DQ. So this, okay, this element, the front element will always be the maximum. We will maintain this. Okay, we are just let us suppose for now that this element will always be maximum. So we will take it out for that window. But what happens if this window, if this element means DQ dot front का जो इंडेक्स है, DQ dot front is obviously an index because we are pushing indexes. If DQ dot front is equal to I minus k, equal or greater than I minus k, what does this mean? This basically means that I is the current index and k is the window size we are taking. So we are at I index and we will go backwards k times. Okay, this must be the size of the window, right? This k from I to k backwards. But if the DQ dot front is further less than that, DQ dot front, that's the index, it's further less than that, then we have to remove this element, right? Because it doesn't belongs to this window. We will see this in this example later. So in this case we will just DQ dot pop front, we will pop from the front. Okay, this is one condition, and second condition is what? Okay, right. Wait a second. Yeah. Fuck it. Okay, we will push it later. Okay, this is the first condition. Now the second condition will be, so now we have to do one thing. We have to maximize the front element, right? The front element should always be the maximum. So while dq is not empty, we will do what? If the dq is not empty and the element at the front, sorry, at the back, see there, let's say there are these elements and a new element is coming, what we will check? If this element is coming element is greater than this, if it is, then we will just remove it. If the coming element is also greater than this, then we will remove it also. So whatever elements are less than the coming elements from the back side and they are in the queue, we will remove those elements because we have to take the maximum only, right? So if the nums of dq dot back is less than or equal to the nums I which we are currently at, we will do what? We will pop back dq dot pop back, okay, and then we will just push the element, the current element in this. If even it's not, if it's the smaller even, if let's say this is smaller than this, then we will just push it here, okay, we will just push the current element nums I, okay, and then if I is, so when we will have the first element in our answer array, when we have the window size done, right? At this point when we are at 1, we will not output anything. Why? Because the window size is still incomplete. But the window size is still incomplete. When we are at -1, then we will know that window size is complete. So when the I is greater or equal to k minus 1, means when I will be at 2 in this case, k minus 1 actually, when I will be 2 in this case, then we will start outputting the elements and we will output what? We will do it like this. In the answer array, we will push back what? Nums of dq dot front, because dq dot front has the maximum element with it, and we make sure that we made that sure, okay, that it has the maximum. So these are the 4 steps. First this if condition, then this while condition, then we will just push it, and then this if condition. This if condition is nothing that we have to output the element or not. After the third index, in all the cases that if condition will be true, because we have to output an element in all the cases. We have a window complete because, okay. So this is the thing here, and yeah, let's try to implement this now. So we will take a dq or d, I guess syntax for dq in C++. It's dq, I guess. Yeah, creating a dq. Okay, dq it is. So dq of integer, let's say this, and vector of answer, let's say this, and we have the k already with us. So we will do what? We will just take n as nums dot size, because we will need n at all of times. So we will start doing I0 to n I plus plus. So first thing, we will just push the index here, okay, and if I is greater or equal to k minus 1, we can output an element now. Then we will just push back, and we will push back the front element of dq dot nums dq dot front, okay, because we are storing index in it. Now the condition happens here is that we have to maximize the element at the first. So we will run a while loop while the dq is not empty, and the coming element is greater or equal to, is greater or equal to what? Nums what is present at the back of the DQ. Then we will just pop those elements from the back side. Okay, now we see this example here, that when we are at 3, this is our DQ, this is our DQ. Okay, when we are at 3, we will just push 1, sorry 0, the index of it. When we are at 3, our index is 1. We will see Q is not empty, and is the DQ dot front, that's 0 in element. Should this element which is already there in the front of the queue be included in the current sliding window? Because we are here and a window size is 3, so this element and 2 elements prior to this can be included in the window. So obviously we have 0 and we are at 1, so it can be included. So DQ dot front is 0 and I minus k will be 1 minus 3 minus 2. So 0 is greater than minus 2, so it can be included, right? DQ dot front is, okay, it should be less than, actually, less or equal to. Okay, so we will keep the 0, we'll go to the while condition. Is DQ empty? No. Then we will check that is 3 greater than the element present at the back of the queue. Q has only one element, so we'll check is 3 greater than the element at this index. 3 is greater than 1, yes it is. Then we will remove this 0 and we will insert this 3's index, that is 1 here. Okay, then is the window of enough size that we can output? No, it's not yet. Then we'll come to minus 1. Okay, is the queue empty? Yes, it is empty. Should the element be included which is in the queue in the current window? Yes, it should be included. Then we'll go to the while loop. Is the element at the back of the queue with this index, the element, is the coming element greater than that? No, minus 1 is not greater than the number at index 1, that is 3. So we will just push 2 here, we will not remove 1. Now we have an index, now we have a window of size of where this condition is true, that I is greater or equal to k minus 1. So I 2 is greater or equal to k minus 1 2. So we have a window now 1 3 and minus 1, and what is the maximum of it? Whatever index is the front of the queue, the element for this index is the maximum. So it is 1, so we will just push in the answer nums 1. Nums 1 is 3. Okay, and in the similar way we will now go to the next index, that is 3. Okay, and for the index 3 we will check that there are 2 elements in the queue. Is this condition still true? Because for minus 3 this is the window, right? And if this is the, okay, this is the window for minus 3, and if this is the window, we know that 3 can be there, so 1 index can be there, it's fine. So we'll go to the while now. While is the last index, last element in the queue, is the number at this index less than the coming number? The coming number is minus 3, it's not greater than minus 1, so we'll just push it directly here, which is 3 index. And again we have to return we return the front of the queue is 1, again we will return nums 1, that is 3. So this way it will be done. Okay, it's clear now. So we have to write the if condition here, that if the DQ is not empty and if this DQ is not empty and DQ dot front, the index there, if it is even equal to like greater or equal to, less or equal to obviously, but if it is less or equal to I minus k, then we will just DQ dot pop from the front. Okay, that is fine. So yeah, I guess we are good with it, and we will just return the answer here. Is this fine? DQ dot push Okay, we have to specify from where we are pushing it, from the back or front, because they are both possibilities. It's not like a normal queue where we can push only from backwards. So yeah, it's good. And if we submit, yeah, it's done. So these were the 2 questions for today, and I hope they were well done by me. So the next topic we will have is, we have done the sliding window as well. Next topic is the linked lists, and we have 11 questions there. Okay, we have done these two, some, I don't know when, but yeah, we'll just clear them out. We'll do them again, obviously. So yeah, these are the questions, and we will try to do them from tomorrow. So that's it for the today's video. We have a 40 minutes video. We are done good because there were 2 hard questions and these 2 really good concepts, so we did them well. So that's it for today. We'll meet tomorrow again. Bye.